So these are the notes for 3.3/3.4. And it's all about properties of logs. So we went over some properties of logs in 3.2, where we put something that was in exponential form into log form and vice versa. So we're going to still need to know how to do that, but we're expanding the types of things that we can do with our log functions. So the first thing in example 1 is our change of base formula. So I had mentioned this in 3.2 that some calculators are able to change the base, but most calculators can't. So it's hard to evaluate a log in a calculator unless it's the common log, which is just log base 10. But using the change of base formula, we can evaluate the log of whatever base it has. So our change of base is the log of the top, the big number, goes on top, so log of 25 over log of 4. And then we just put this into the calculator. Be careful when putting it in the calculator. Some calculators are smarter than others, so you may have to just do the log of 25 in parentheses and then divide it by the log of 4. Or it'll give you the log and then you have to close the parentheses on the 25 before you put divided. Or you could always just say the log of 25 equals and then divided by the log of 4. So when we put this in the calculator, we should get 2.32. For B, we do the same thing. It's always the bigger number on top, so it'd be log of 12 over, think the base goes on the bottom, so log of 2. So base is on the bottom. And then we just put this in the calculator. You have to do log of 12 divided by log of 2. You can't just divide 12 and 2 and put log of 6. It does not work that way. You have to do log of 12 divided by log of 2. So when we put it in the calculator, we get 3.58. So make sure you guys are practicing putting these in the calculator and you understand that you know how to use your calculator. Example 2, we're doing the same thing. So it's the same change of base, but we're using natural logs. So it works the same way if you did ln of 25 over ln of 4. Because ln is the log base e, so as long as they're the same, this is technically log base e of 25 over log base e of 4. So it still works out. So when we put this in the calculator, we should get the same thing we got from before, which is 2.32. Same thing with the second one. We can put in our calculator ln of 12 over ln of 2. Remember, the base goes on the bottom. Same thing here. Base goes on the bottom. So when we put this in the calculator, we should get the same thing we did in the last question, which is 3.58. So you can use the change of base using the natural logs, which is ln, or using the common log, which is just log base 10, but you don't have to put the 10 because it's just implied that the 10 is there. Your calculator automatically makes it a common log. All right, next, we can expand and condense log functions by using these 3 properties. So when we multiply 2 numbers together, we can split it up with addition. So multiplication goes with addition. If we're dividing 2 logs together, we can split it up with subtraction. So division goes with subtraction. And then if we have a base raised to an exponent, any exponent, that exponent just goes to the front of the log. So whatever exponent we have, we can move it in front of the log, just like it is here. So these are our 3 properties. We have the product property, quotient, and power property. It's important to know that anytime you split it up, if I had the power property, it's just a log of 2 things, but when I split it up and break it up into the log of u plus the log of v, they each get their own log. So anytime you break it apart, each term gets its own log. Same thing with division. When I break it up with subtraction, each term gets its own log. And then the same things work with the natural logs too. So instead of log with whatever base, it's just ln, but it's the same properties. So example 3. It says write each logarithm in terms of ln of 2 and ln of 3. So we want to think, how can I make 6 in terms of 2 and 3? Well, 6 would be 2 times 3. So this is now the ln of 2 times 3. I didn't change the numbers here. I didn't change the value. I just changed the way that it looks. So now I can use my products property, and I can split it up with addition. So I can make this it's ln, make it ln of 2 plus ln of 3. Every time we break it apart, each number, each term, whatever it may be, gets its own log, or its own ln. So we're going to do the same thing for b. This is our answer. It just wants everything in terms of 2 and 3. So for b, we're doing the same thing. I already have a 2 on top, but I want to change 27 to be in terms of either 2 or 3. I know 27 is 3 to the third power, so I'm going to make it 3 to the third power. Now I'm dividing here. So when I divide, I can split it up with subtraction. So this would be ln of 2 minus ln of 3 to the third power. So I did my division, I split it up into subtraction, and every time you split it up, each term gets its own log. Now I can just split this up a little bit more because I have an exponent here, so I'm going to do the power property and move that in front of the ln that it's attached to. So don't move it in front of the whole thing, just that one piece. So this would be ln of 2 minus 3 ln 3. That's our answer. If you put this whole thing in the calculator, it would equal the same thing as if you did it in multiple steps. Obviously, it wouldn't really be easier to put this in the calculator, but we're just practicing our properties of logs. So in a lot of these questions, it'll be with variables, and we're just going to split it up to expand it or condense it together. Right, in example 5, we're using the properties of logs to expand. So every time I break the log apart, each term gets its own log, and that log with the base stays the same. So it's log base 4. Every single time I break it apart, it's going to have a log base 4, log base 4, log base 4. That 4 is just attached to the log. Now, in here, I have 3 different terms. I have 5 that's being multiplied to the x cubed, and I have y that's being multiplied also. So I'm going to break it apart. We know that multiplication goes with addition. So when I split it up and expand it, I'm going to add them all together. So I have log base 4. That log base 4 doesn't change. The 4 stays attached to the log. Log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Every single time we break it apart, each term gets its own log. Now I know I'm repeating myself over and over, but this is one of the most common mistakes that people make. They break it apart and just put plus without the log. You need the log every single time you break it apart. Now we're almost done. I have that exponent there, and that exponent just goes right in front of the log that it's attached to. So this is now 3 log base 4 of x. And the rest of it just stays the same. So I have log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. And that's my answer. All right, now let's look at B. So for B, I'm dividing. So I know division goes with subtraction. So I can just break these apart right off the bat and subtract them together. So I have ln of square root 3x minus 5 minus, so when I break it apart, each term gets its own ln, so ln of 7. Now I'm only dividing 7, so 7 is the only thing that gets that minus. I haven't done anything else, just split apart that division sign into a minus. Now next, I know what to do when I have an exponent, which the square root is essentially the same thing as an exponent. The square root is the same thing as saying to the 1/2 power. So this is ln of 3x minus 5 to the 1/2 power is minus ln of 7. So now I can use my power property and move that 1/2 in front of the ln. So this would be 1/2 ln of 3x minus 5 minus ln of 7. So this would be our answer. I can't break apart 3x minus 5 because I don't have a property that works like with subtraction, because I only can go from division to subtraction when expanding. Here I can't expand this anymore. So that 3x minus 5 is just one term. We're just taking the ln of it. So just make sure you move the exponent in front, and then that's it. If it was something like 3x, if I had ln of 3x without the minus 5, this I could expand into ln of 3 plus ln of x. Or even if it had that 1/2 still in front of it, so 1/2 ln of 3x, I would expand this into 1/2 ln of 3 plus 1/2 ln of x. But because that minus 5 is there, we can't break that apart. It's just one thing. So these are just examples. But this would be our answer. All right, now let's look at example 6. So here we are condensing our logs. So anytime we have a coefficient in front of the log, we do the opposite of the power property. We'd take that and make it the exponent. So we would take this and make it the exponent. So it's just the exponent of whatever that log is it's attached to. So to rewrite this one, it would be log base 10 of x to the 1/2 power plus log base 10 of x plus 1 cubed. Now when we condense, every time we condense, we want to condense it to just a single log. So our answer should only have just one log in it. So here I have 2. I'm going to condense with multiplication because I have addition here. So we know multiplication goes with addition. So I just multiply the two things that I'm taking the log of. So this would be log base 10. The base never changes, it just stays attached to that log. So log base 10 of x to the 1/2 power times x plus 1 cubed. And that's our answer. All right, now with B, I'm going to write it down here. So anytime I have a coefficient, I want to put that up top and make it an exponent. So this would be the ln of x plus 2 squared minus ln of x. Now we know minus goes with division. So I'm going to divide my two terms here. That ln gets condensed to just one ln, and the two things that I'm taking the ln of is what I divide. So this would be x plus 2 squared divided by x. That's our answer. Once we get it condensed down to 1 log or ln, we are done. All right, for C, I have that coefficient of 1/3 in front of everything. So I could distribute it to this log and to that log. So it would be 1/3 log base 2 of x plus 1/3 log base 2 of x minus 4. Now I always want to start with moving my exponent to the top when I'm condensing. So that goes on top of the x and on top of the x minus 4. So log base 2 of x to the 1/3 power plus log base 2 of x minus 4 to the 1/3 power. And then here I'm adding, so I know addition goes with multiplication. When I condense it down to a single log with the same base. Base never changes. So log base 2, and I multiply the two things that I'm taking the log of. So x to the 1/3 times x minus 4 to the 1/3. That would be our answer. Another way we can do this one, I'm going to write it down below here, is that I can condense the inside first. So I am adding, so that means I multiply. So I'm going to multiply the two things that I'm taking the log of. So this would be 1/3 times log base 2 of x times x minus 4. Now you don't have to distribute it, you can just leave it there. WebAssign may want you to distribute. So if I had to distribute, just distribute that x to both things on the inside because we're multiplying them. If not, WebAssign would probably want you to keep that in parentheses too. So this would be log base 2 of x squared minus 4x. And then the last step here is I can move that 1/3 up top. So that would be log base 2 of x squared minus 4x to the 1/3. So these are the same thing. They just look a little bit different, but that's fine. So here I just had to distribute the x into the parentheses. Again, WebAssign may want you to distribute it, but you can always just click like check another and see how it wants you to leave the answer. All right, so this is going to be part 1. We're going to do the rest of them with solving tomorrow. So I'll be there tomorrow. We'll do the second part. Your WebAssign will be due on Wednesday, and I'll also post the test review. That way you can take a look at it. Our test is Thursday.